All right. So, what is Java? What Java is? Here we give you a definition. Java technology is both a programming language and a platform. That means Java technology is not only a programming language. You know, the C or C++ is only a programming language, but Java is not. It including a programming language and a Java platform. So let me see the first concept about the Java programming language. The Java programming language is a programming language that uses both compiled and interpreted technology. Well, what is the compiled? What is the interpreted? The two different technologies used by almost all of the programming languages. But Java uses both of them. Well, why? Let me give you an example. Here, let me give you example. Well, here is you, and let's say you have a smart light. Here's a smart light. Yeah, smart light. A smart light can only understand two commands, on and off. If it get on, the smart light will turn on. If it get off, the smart light turn off. But the smart light can't understand what you say. So if you want to control the smart light, you need an agent. Suppose here it's an agent. The agent can understand what you say and convert it to the commands that the smart light could understand. So suppose one day you see a lot of words to agent like hi, buddy, I'm tired, turn off the light. Well, well, here we see you have the four sentence. Hi, buddy, I'm tired, and turn off the light. And agent, if you have the agent with interpreted technology, what the agent do? Well, he will translate all of things to a smart light. Suppose the smart light can stand on and off, and another command is do nothing. We limit as not available. Well, this is commands a smart light can stand. Not available, that means do nothing. On, that means turn on. Off, and turn off. Okay, so the agent will convert your words to the smart light one by one. So to convert the smart light as first one is do nothing, The second, do nothing. The third, I'm tired. Oh, do nothing again. What the last one is, it's a real command. Turn off the light. So, off. So, this is what you say. We give its name as source code. And this is the agent. Convert what you say to target. So we name it a target. So the target code is do nothing, do nothing, do nothing, and off. So smile turn off. It's an agent with interpreted technologies. It work like this. But if you have an agent with compelled technology, suppose this another agent, here's agent A, well, with interpret technology, and here's agent B with compare technology. And you see the same word and how the agent do. Well, the agent will listen all of your words. Hi, buddy, I'm tired. Turn off the light. And he understand it. Oh, what to say? The first one, second one, third one, it's nonsense. Too smart night. So you convert what you say to the target code only include the off command. So this is agent with compare technology. This is agent with interpret technology. So in the summary, the agent technology with interpret technology, the agent with interpret technology will translate your words, your sentence one by one to the target code. And the agent with comparing technology will understand what you say and make some kind of optimization and remove something redundant or nonsense. So the target code comes out at the result of compile. It have smaller size than the target code comes from the interpret technology. So it's small. But on the other side, if the agent, this agent B, is equipped with the comparing technology, for doing the comparing, it must understand all the words you have said and do some processing. That means this agent must have enough memory, like your brain. Your brain to remember a lot of words you have heard and then understand them and extract the real meaning. So the agent with compare technology need more powerful compute processing. So that means if the agent B is much more powerful computer. But the agent A is kind of silly, but it only need a NES power than the agent with comparing technology. So it's less power, but the target is big. And the agent B with comparing technology, the target code is small, but it needs powerful processing. So this is the two kinds of technologies, the comparing technology and the interpret technology. So now we understand what the two technologies mean, why the Java language uses both of them. Okay, well, here's a picture. Show your whole process the Java do. Both use compiler and interpreter. At the very beginning, we must write a source code. Here's the source code. The source code is the text file. Text file, yeah, inside it's our code, source code is here. Source code, here's my source code. We limit something dot the Java. And before we execute, we must use a compiler. Here's a compiler. It's like the agent as example have given you as the agent A. Yeah, you have the compiler technology. Oh no, it's agent B. Yeah, it's agent B. Yeah, agent B equipped with compile technology. Understand what you say. It understand each line of the code and make some optimization. And as a result, we get a class file. The class file will limit as bytecode. Another name is bytecode, but this code cannot execute it directly on the target machine. Here's my target machine. The target machine is just like smart lighter. Yeah, smart light only understand the command not available on and off. The machine code can understand the source code. So after compiling, source code has been compared to the code, to a bytecode that the smart light can stand. That it's not available, that it's on and off and not available. So this command can be directly executed by interpreter. So interpreter here, interpreter gets a command. Its command is here. It's like what you see. Oh well, let's see. Yes, a lot of variable. Yeah, so another variable and a lot of variable and a lot of variable and oh yeah. If directly convert is what you say from a source code, it should be not variable, lot of variable, lot of variable on, and get it to a target. And the target will do the job, is turn on it. But if you use a compiler, we get a result as only one command is on. So the smart light is on. So this is why we use a compiler during this process. We need a small, enough small for the size of the code. Why we need a small code as a bytecode? Because this code will be delivered on the internet. It's a very important feature of the Java programming language. We made the code delivery on the internet. So we need small size. A big size in that day, the 90s we have poor internet connection. So if this code is too large, it cannot deliver it through internet. So we need smaller size. This process, because user compiler, it must be implemented on a powerful computer. So the compare process will do its job on the PC. The PC have powerful computing ability, a powerful central processing unit, and enough memory that can do the complex job. But the smart night, the Taki machine, in the Star 7 project, it's a kind of tablet. It was poor energy, poor processing energy. So this step execute the bytecode we use interpreter. It not need powerful computing. Don't need complex processing, complex algorithm, and just translate each of the word and the word is on. So this target code is on. The target code is on. So here the interpreter can understand the, the bytecode. The bytecode, yeah, the bytecode, understand it. It's all of the words from the bytecode. Like it's not available, like on and off, and here a command is turn on. So it's turn on. So this is why we use compile technology and interpret the technology as well during the whole process, because the few feature of this language. This is a very important idea. And here we got the concept of bytecode. The bytecode is the result of the compiler from the source code. And this bytecode cannot execute directly on the platform. So we need an interpreter to interpret each of the words inside the bytecode and convert to the target code, the machine code of the target computer. So give the name also of this interpreter. We'll give another name is a virtual machine. We name it as Java virtual machine, short as JVM. That's the idea. Now we have a JVM. An interpreter can translate a bytecode as a result compiler to the machine code. The machine code understand by different kinds of computer. Here we have example. Here is three different operating systems. Here is a Windows. Here the Unix Solaris system is another. Well, it's just Apple, the Mac operating system. It's a different kind of system. So we have different format of this machine code, but on this different kind of operating system, we have interpreter. The interpreter, the Java virtual machine, can convert the bytecode to the different machine code. So we only write one program and compare it, we get one class file. And this class file can run on the interpreter and the JVM, because JVM can understand all things of the bytecode are converted to the machine code. That machine code is dependent on different operating system. It can have different format, but whatever, you can do it because we have the JVM. It's just like we have a wrap. We have a wrap up all of the different kind of system and make them become only one kind of type of machine, that is JVM. So we have this very important feature of the language, that it's a programs can be written only once and run on almost any platforms. It's a very important feature. It's why Java is a very powerful language. It's what we should learn it because we only should learn one kind of language and will do programming on different kind of system. It's quite convenient as a programmer, If you want to program for different operating system, it's a really tough work. You must understand different format of machine code and use different development tool and quite a long time if you should cost you to learning these languages, and it's a very tough work. So, but if you master Java programming language, and it's become a really easy work. You only store the JVM on this machine, install JVM on another machine, and you write one code and deploy the code on a different JVM, and your test is done. Now we understand what the meaning of the Java programming language, and we can use the programming language to write the source code and use a compiler to convert the source code to binary code, to bytecode. But the bytecode cannot run directly on the target machine because they have different format of machine code. So we need a JVM, a virtual machine, an interpreter to convert the bytecode to the target code, to target machine code. So the JVM is a key part of the Java platform. And the Java platform has include two parts. The one is the JVM, and another one is the programming interface. We name it as Java API. And about the JVM. The JVM, as we know, it's an interpreter, and it converts the bytecode to real machine code, so we can think it's a kind of machine, a kind of imaginary machine. Why it's called it imaginary machine? Because it's implemented by software, mainly by software. So it's an imaginary machine. We can see the shape of the machine. A real machine has the shape. It's like a box, like a circuit, but imaginary machine, it's implemented by software. We cannot see it, but it's real existed. Its function is to convert the bytecode to real machine code. The bytecode, we store this bytecode in class files. Inside class files is our bytecode, and we convert this bytecode to different machine code, the target machine code. Its format is different depending on the different real machine, real operating system. Currently, we have designed different kind of JVM for different kind of system, different kind of machine. So on common machine, you can find the suitable JVM and install this JVM on the machine. And so you can write the Java code and compare the bytecode, and the bytecode can run on the JVM on this different kind of real machine. Even in the browser. In the browser, we have a small JVM and designed especially for the applet, the kind of the Java products can run on the JVM inside the browser, and it's implemented by plugin technology. We'll talk about it in the chapter about the Java applet in the future. So this is about the JVM. That idea of the JVM. It's an imagery machine that is used to convert the bytecode to real machine code. And another part of the Java platform is API, Application Programming Interface. Yeah, it's what is about API? It's a ready-made software component. What does a ready-made software components mean? Well, let's see. Now you have the task to write a code to print something on the screen. How to do that work? You don't know because it's complex hardware related work. You don't know how to send signal to the display screen. Well, it's very complex. So how to do it? It's very lucky for us. We don't need to understand how it works. And even we don't need write the code for real hardware. We use the APIs. The APIs are this code write by the designer of the Java platform. They write the code for us. Simply just use them. Use these APIs in our code. Here's what the idea of the APIs. So the APIs in the future, we'll talk about the APIs. We'll store the libraries in Java programming language. We use packages, use this idea to describe these different libraries. Inside the libraries, we store lots of different APIs that we use for different kind of tasks related to hardware. For example, the screen, the keyboard, and the sound effect, a lot of different work. Now we have the APIs, and we have the JVM, and we bound them together and get the platform, the Java platform, as shown in these figures. The Java platform, and the Java platform, it's a middle layer that will make us not depend on the hardware at the bottom layer. It's just like we wrap the hardware platform, use the Java platform. Use the Java platform, we make all the different kinds of hardware platform the same one to the Java code on the top layer. It's the same. We use the same class file format for the Java program. And the JVM can understand the same format of the class file, the bytecode, and convert them to different kind of machine code, which is dependent on the different hardware-based platform. That is why the Java has the very important feature that written only once and run anywhere. That's the idea.